Hi everyone. We'll continue our series on data analytics techniques. Today we'll be talking about knowing the right visualization and analysis to run based on your data as a data analyst. Like we've always said, this is the part 8 of the series. If by chance you missed anyone, I would recommend you pause this video right now to go check out the previous ones because the learning are building up on one another. In today's talk, I'll be mentioning a lot of concepts that have been discussed like in the previous videos. So that's going to be helpful for you if you haven't watched the previous videos. So just quiet to watch the previous videos. So the question is, why do I need to know the right visualization? So most times what we do as data analysts in our everyday work would be something similar. So let's say you get a job with, say, company organization. So the kind of analysis that you would run for that organization would be a little bit sort of limited. You would be doing almost the same thing over and over again. There are some organizations where you do different kind of analysis, but even as data analysts, there are like some fundamentals that you have to understand because whatever software you're using or whatever package you're using to run your analysis works with Gigo. So it is basically garbage in, garbage out. If you type A, it's going to bring out A. So even though you run a visualization and it brings out a result, your software or your device will not tell you, oh, this is wrong. And that is where human thinking comes in. And so in case you're afraid AI would replace um a data analyst role, so there might be some parts that would make it easier to do some analysis. But for the most part, some of the tasks or what we do as data analysts or data experts require some critical thinking. So it just also allows you to know like the data type. So today we'll be talking a little bit about data types that we spoke about in previous videos. And why you also need to like know the right visualization is so that it makes you know what a good result or a bad result looks like. And it also makes you know what your visualization and your result will look like even before you do your analysis. And from you perceiving the work of others, you can be able to say, oh, this person did the right thing, or you can evaluate another person's work. That's if they are like a new data analyst or so. So it's very important that you know the right visualization. This is one of the most important discussions you would need to learn for your data analysis techniques. So we need to do some basic recall of information. So we have um, different levels of analysis. So if you go out on Google, you might find under information when you see what are different levels of analysis. But in this context, so what we mean is univariate, bivariate, and multivariate. So univariate analysis is when you are working with just one variable. So in this instance, income. Bivariate analysis means you are working with just two variables, so maybe income and age. So when we mean working with one or two variables, doesn't mean in your data set you only have one column or two columns. So you can have multiple columns, multiple variables, and let's say when you talk with your stakeholders, you're interested in knowing the income, like you want to do analysis of just one variable, you want to do the analysis of how does these two variables relate. So that is bivariate. So if you want to say how those three or more variables relate to one another, that is multivariate like analysis. So that is so now the question of today's discussion is, so what kind of analysis do we run when we are just trying to run just one variable, or what kind of analysis do we run when we have two variables, or what kind of analysis do we run when we have three or more variables? So even when we have one variable, remember that we have data types. So in data types, we spoke about numerical variables and categorical variables. I am saying all of this concept on the assumption that you've already watched the previous videos or you understand this concept I'm mentioning. So if you have just one variable, or we know there are data types called numerical variables. So for example, a numerical variable is income, height, salaries. So the kind of analysis that you would run for a numerical variable, that's a variable that is sort of in numbers is you would run something like measures of central tendency. Measures of central tendency include mean, median, mode, range. And so let's say you are given a variable that is a number like age or income or height or salary. So you can ask yourself, what is the mean income? What is the average income of everyone in this survey? So those are things you can do. Another thing also you can do is an histogram. So you can do an histogram for a numerical variable, or you do a line graph. Doing a line graph is not something that you do for the most part because it could be tricky. So doing a line graph is when you have a categorical variable that can also sound continuous. And most times a variable that is like that is something like a variable that is like years, so or months. So months would serve as a categorical variable, or it would also serve as, but it's more leaning towards a categorical variable. So when you have variables like months, like years, so variables that in a way they are categorical, but they sound as though they are continuing or they are continuous, compared to, imagine you are using location. Location is a categorical variable, but it doesn't sound continuous. So you can do a line graph. But I mean, the major things that you would do for like a numerical variable, like you do a measure of central tendency or you do an histogram. The reason why you do an histogram is to look at the distribution of the your numerical variable. So I will show you example what an histogram looks like, and then we'll talk more about that. So the kind of analysis that you should not run for a numerical variable, if your data is a numerical variable like income, like height or salary, is you should not do a bar chart or you should do a pie chart. You should not. That's like totally like wrong. So let's show us like some examples. So remember we are talking about numerical variables. So this is we are not showing us mean median here because mean or median or mode or measures of central tendency is just one number that you're gonna get. So imagine you have a variable called like age. So this is an histogram, and one of the things that would make you we'll talk about this also like in the next slide. So this is an histogram. So one of the things why we do an histogram is to look at the distribution of the data. So ideally, we want our data to be distributed in such that it is going like in a way slow up and coming down. So the reason why we want that is so that means it is evenly distributed. So when we mean evenly distributed, doesn't mean that it's like going on a straight line. So one of the laws of being a data being evenly distributed is that from the lower end, it is like low, then it goes up, then it comes down. So that is how we think a data is evenly distributed. So also we can, if a data is not evenly distributed, it could be skewed to the left or skewed to the right. So skewed to the left means that we have more numbers that are, so more of the numbers that we have here are like smaller numbers, and we have very few numbers that are like bigger numbers. So it means in people's age 20 to 100. So from this visualization, we can see that we have more younger persons compared to older persons. So that is one thing you could see from like visualization, right? So you could get to know that when you do your mean or your median, or sometimes it might not show you well. And another thing also is if you notice that your data, it's a little bit, you have younger persons more or older persons more, that could also lead to bias in your analysis or like your result not being accurate just because you have some outliers. Um, outliers, we've already spoken about that in previous videos. So most times we run histogram just to investigate numerical data. So someone who is not like a data expert or who doesn't familiarize themselves with data a lot might not understand what histogram is. So there's a way we can investigate categorical variables. There's a way we can also investigate numerical variables. So one way to investigate if a numerical variable is okay is to run an histogram. So this in a way is not bad, like what we have here. It's a little bit skewed to the left, but If you find some that are very funky, for example, you find one where for this 20, the bar is just too high, and for others, it's like very, very low. So those can give you an indication of, oh, probably I should take those who are around 20 something. So this doesn't mean that what you have in this data is 20, 30, 40. So you have people at 21, 22, 23, and all. So one thing you need to notice about this histogram is that there are no space in the bars except for this. And this is like some, probably this is just showing that you have, this might be, there's something here, but it's probably just very low, or maybe you just have one or two persons. So there are no space in the bars for an histogram. So this is an histogram. So this is a line graph that I spoke with you about. So a line graph that you can run for a numerical categorical variable. So you see here that we have the years. So it's showing more like a line. You could also do like a bar chart, and we'll show you what a bar chart looks like in the next slide. So you could also do a bar chart for this, but as someone who wants to do something very funky or something very interesting, if you have your categorical variable that sound continuous, most times there are really not a lot of categorical variable that sound continuous. So most of them is like months or years. So you just use a line graph. Now, this is an example of a bad um, visualization. So this is a pie chart. Remember, this is a line graph. This is an histogram. This is a pie chart. A pie, like for those that know apple pie, or you get to take pizza. So this is a pie chart. So remember, we spoke about the fact that you should not run category. You should not run pie charts for a numerical variable. So imagine this is a number from 1 to 9. You could see what they did here was they grouped everyone 1, 2, 3, 4, 6. So imagine the age. We are doing this for age, and we have 20 to 100. So what you are going to have here is just going to be 20, 21, 22, 23, all the way to 100. And this bar, this pie chart is going to look very messy. So try to ensure that you are not running a pie chart for a numerical data. Like, it doesn't work. It's a violation. Um, so still on numerical in a very level of analysis. So another type of data is categorical data. So for categorical data, we have data that are like in either dichotomous or ordered level categorical data. These are in categories, right? So we have sex. So you have like male or female. That is like distinct. You have rurality. You have product type. You have wealth status, rich or poor, height, tall or short, things like that. So the type of analysis that you would run would be bar charts, pie charts. You can do a table. You could also do a line graph. So line graph fits in for like a numerical and categorical data also. So others are like donut chart, bar of pie. So donut chart and bar of pie are not something like very common. But this basic bar chart, pie charts would serve you. So sometimes you might worry that, okay, when should I run a pie chart or a bar chart? So bar chart is widely used compared to pie charts. And so there are instances where you might just want to run a pie chart. Let's say you are running analysis and almost all the results you are doing it in a bar chart, and you want to do something a little bit different. You can say, oh, let me just insert a pie chart somewhere in my results, and such that I don't have like something monotonous. And that thing where you might think of a pie chart being okay is if your your levels in your categorical data is just very few. So imagine we have something like sex, right? So probably for now we are sticking with male and female. For you to do a pie chart, it would be okay. But if you do something like let's say geographical location, or something like north, south, west, north central, let's say you have about 5 or 6, it's going to look a little bit messy if you use a pie chart. So you might just want to use a bar chart. So if you have more levels in your categorical data, might want to use a bar chart. So tables is like it. A lot of people don't like using tables, but sometimes tables are very good just for you to show something simple. Like I said, you want to have a mixture of visualizations in your analysis when you're writing a report, so it doesn't look like you're just doing the same thing. So the kind of analysis that you can run for a categorical data is measures of central tendency and also histogram. So for example, you can, what would you mean when you say what's the mean sex? So that doesn't make sense. So the mean rurality, it doesn't just make any sense. So even though you represent sex as 1 and 0, or you represent them as 1 and 2, like with numbers, so if you add that together, 1 plus 2 is 3, 3 divided by 2 is 1.5. So you say the mean sex is 1.5. So that is not the result. Even though your software can give you that result, you can run a like measure of central tendencies with a categorical data, or do an histogram with a categorical data. Now let's show you something of example of a bar chart. So this is a bar chart. This is a bar chart here. Now, one thing you want to do is, like, anytime you see a graph or you see a chart or anything, try to pay attention to a few things. Pay attention to the x-axis, pay attention to the y-axis. So this is the x-axis, this is the y-axis. This is the x-axis, this is the y-axis. Also pay attention to if it has like a label, what do they mean? So this is a categorical data that's showing how people agree to something. So it is so strongly disagree, disagree, neutral, agree, abstinence. So sorry, strongly agree, right? So we have 1, 2, 3, 4, um, 5 options. So what happened is, so the kind of data structure that you would find for this is, so let's say we have about 100 rows. So that is, and we just have one column, right? Imagine this is a column for this is a column here. Let me use this. Imagine what we have here is level of agreement. So in that level of agreement, so what you have is something like strongly agree, strongly agree, strongly agree, disagree, disagree, disagree. So what a bar chart does is that it counts how many times do we have strongly disagree in this. So it's 10. How many times do we have disagree is 9? How many times do we have neutral is 25? How many times do we have agree is 30? How many times do we have strongly agree is 4? So this gives you like a result and say, oh, most people in our results are actually leaning towards agreeing to this particular question. So it's just one. Remember, this is a univariate level analysis. So this is a categorical variable. So you are just running just based on one, not thinking of another variable, right? So this is how people agree to something. And on the y-axis is a count of it. So there are other bar charts that on the y-axis is something else I say. So pay attention. So if you see a bar chart, for you to know if it's a univariate bar chart or bivariate bar chart, you need to look at what is the y-axis. What did they write there? So they says opinion frequency. So for you to know it's a univariate, sometimes it will be count, sometimes it will be percentage. So percentage, count, frequency, it means this is a univariate bar chart. It's just a bar chart that is standing alone. So another thing is that you can do for a categorical data is look at this. This is a pie chart. So they did this like tea, coffee. So you can identify, oh, which one is water. So this is water. This is other. So right, you don't have so many levels. That's why this looks a little bit nice. So imagine somebody's writing a report and the person also did like a bar chart again for something like this, because you can run a bar chart for this. So this makes it look, oh, something a little bit different. And that thing also, it's like you do a table. So this is a table. So imagine we're doing a bar chart here. We just write a table and say strongly agree 10, disagree 9, neutral 26. And you can just order them in from highest to lowest instead of the way this is ordered from, like, not, there's not ordered, right? So this is a table. So how many people were abstinent, how many people used condoms, how many people used injectables and stuff like that, and you write the total. So you might care about, you want people to see the total number, because a bar chart is not going to show you a total number, right? So that is one of the ways you could run analysis for a categorical data. This is a univariate level analysis. So like we just spoke about univariate and And what we spoke about is the numerical and the categorical. So moving on to bivariate. So bivariate is when you are combining two variables together. So one instance is where you are combining two numerical variables. So remember, first instance is when you're combining two numerical variables. An example here is age and income. So age is a numerical variable, income is a numerical variable. So the type of analysis you can run if you have two numerical variables, or you want to see a relationship between two variables and they are numerical. So one you can run is a scatter plot. I'm going to show you what the scatter plot looks like. You could also run measures of central tendencies. You could also run show tables. You could also show correlation coefficients or regression. The type of analysis you would not be able to run. I mean, this is a little bit most likely, I think this would work for almost any both numerical data is you will probably will not be able to run a bar chart or a pie chart. Remember, like you can convert a numerical data to a categorical data through data manipulation. For example, if you have age from say 20 to 60, you can decide to say, I want to group everyone that is between 20 to 40 as one group, 41 to 60 as another group. So that's a way you can do your analysis. But imagine you are not transforming your numerical data, you're leaving both as numerical data. So you have two numerical data. So these are the type of analysis you can run: scatter plot, measures of central tendency, tables, correlation. So when you run a correlation, the result is called correlation coefficient. So when you run a correlation, the result is called correlation coefficient. So so let's show you what it looks like. So imagine we have, so this is a singular analysis, and I need you to pay attention here. So this is the number of falls. So this is the number of vaccine. So I'll take number of falls as, let's say, people will fall sick. I'm just making an assumption, and this is the number of vaccines. So this is trying to say, so anytime you see your this is a scatter plot. Anytime you see it's scatter plot, so remember this is two numerical data. So this is one variable, this is another variable. Anytime you see a scatter plot and the scatter plot is showing you something like this, like it's going in this direction, it means there's a positive relationship between number of those who fall sick and number of those who use the vaccines. It means that as the number of people who fall sick increases, number of people who uses vaccine also increases. Or number of people who uses vaccine increases, the number of those who fall sick increases. So it depends on how which one will come first in how you speak about your analysis. So most times you want to put your independent variable in the x-axis and your dependent variable in the y-axis. So what do you think will be affecting one? So you can think, oh, do we think as people take the vaccines, they would fall sick more? Or as people fall sick, they are taking the vaccine more? So that is like a judgment for you to make. So this is showing that there is a strong positive relationship. So yeah, correlation coefficient runs from 0 to 1. So 0 means there's no correlation. 1 means perfect correlation, and you hardly find that. So when I mean 0 to 1, it also means it runs from negative. So there's also negative. So it's like there's minus something, there's minus. So there's minus also. So, but doesn't mean, but it's technically absolute number is 0 to 1. So you can have minus 0 0.7, minus 0 0.9, minus 0 0.1. So, but you can have minus 1 point something. That doesn't work. So it goes from 0 to 1. So this is showing that there's a positive, strong positive relationship. However, this is like a little bit scattered. This is a little bit scattered. So you see that this is also positive, but this is a weak relationship because it's not like they are not together. So on this other hand, so this is showing that there's a negative relationship, meaning as the number of those who fall sick increases, the number of those who take vaccine reduces. Or we can say that the number of those who takes vaccine increases, the number of those who fall sick increases. So you see the way I'm using the words, right? So as one increases, the other decreases. As one increases, the other decreases. So as this increases, this decreases. Or as this decreases, this increases. So we can say, yeah, as the number of those who take vaccines increases, those who fall sick decreases. So this is a strong negative relationship. So you see how the line is here. So it's going in an opposite direction compared to this. Why this is a strong, this is a weak negative relationship. So try to pay attention to it. So when you use your right hand for the diagonal line, it is a negative relationship. When you use your left hand for the diagonal line, it is a positive relationship. So you could use that as a technique. Well, I'm sure as you work more, you could, when you are trying, if you get a scatter plot result, you can try to look at um you can try to look at or Google what does a strong correlation look like. So that kind of reminds you. So remember, so when you use your left hand as a for the diagonal lines, it's positive, and use your right hand, it is negative. So now let's take an example of what a table will look like. Imagine you have a table like this is a data set. You have the month of employment and you have the month with above average performance. So this is the number of months this certain employee has been employed, and this is a certain number of months they've performed well. So we can run a scatter plot to see if those who have stayed longer. So think about it. So analysis is coming like you have an hypothesis, you have an assumption, you have a question. So the question is, do we think people who have stayed longer in this organization are performing better than people who are just have shorter stay in this organization? So how do we do that? So you ask yourself, is this a numerical variable? Oh, yes. Is this a numerical variable? Yes. So two numerical variable, what kind of analysis do I run? Scatter plot. So you do a scatter plot and it shows you. So whatever the result is saying, then you can say, oh, there's a positive relationship between the number of months of employment and months average performance. So that is it. So if it is negative, then you can say there's a negative. However, if you run a scatter plot, it most times doesn't show you the correlation coefficient. So correlation coefficient and scatter plot is like the same thing. So correlation coefficient would show you a number, while scatter plot will show you the visualization here. So however, you can run it in Excel such that your scatter plot is going to show you your correlation coefficient also in your scatter plot, or you can decide that I don't want a plot, I just want a number that tells me, and interpret based on that number. So other things you can do regression with this. So remember, so it's a numerical variable. There's really not so much of analysis we can run when we just have numerical variables alone. So yeah, most times scatter plots, if you are doing that, is a bivariate level of analysis. So moving on. So imagine you have one categorical and one numerical data right now. So a categorical data is sex and income. So a question here might be like, I want to know what is going to be the average income for male and female. Are the males earning higher compared to the females? So analysis come with asking questions. So from you asking questions, then you start to narrow it down to what kind of visualization can I run. So if you have a numerical data and a categorical data. So type of analysis you can run, it's a bar chart, a bar pie or a pie chart, that it depends, table, line graph, measures of central tendencies. So you see here we have numerical and categorical data. So you can infuse both analysis you can run for numerical data and also categorical data into when you have one categorical and one numerical data. An example here, this is a bar chart. But on this bar chart, look at the y-axis. The y-axis is showing average amount. This is not showing count. This is not showing frequency. This is not showing percentage. This shows us that this is a um a bivariate bar chart. And from looking at this bar chart, so what it looks like is, so they had like the kind of maybe method of payment and the amount they paid for each method of payment. So the categorical data here would be method of payment and the amount paid. So I could read this just by seeing the result, knowing that this is a bivariate bar chart. So this is the categorical data. So, and most times on the x-axis is what the categorical data will stay, and on the y-axis is where the numerical data will stay. So if you are combining two variables, that's one categorical and one numerical data, and you run a bar chart, it's going to give you this. And there are instances I want to know what is total amount people have spent when they use credit card in our company? What's total amount people have spent when they use debit card in our company? So we can know, let us as an organization focus on, or let us make it convenient for people to pay with check or pay with digital wallet. And we say, oh, most people don't pay with cash. That means that the world is going a little bit digital. So these are insights you can use. So let's take, for example, we have this. This is a bivariate, right? So this is a categorical data. We have Alabama, Alaska, Arizona, and you have this is average AQI. Now, most times data structure don't always come like this, where everything is like counted from. For example, you can have Alabama. Imagine we have Alabama 4 times, and we have like the average AQI like in multiple places. So what this would do is that it's going to add up all the Alabamas together and give it together. It's going to add all the Alaska together and put them together. But because you just have just one for each, so if you run a bar chart with this, so on the x-axis, you're going to have Alabama, Alaska, Arizona, digital wallet, cash here, and you are going to have the average AQI like on this x-axis. So what would happen is the lowest that would be here is 118. So you have Alaska first, and it's probably the bar is going to be around here, and Alabama will be next, and things like that. So you see how it works when you run a bivariate bar chart, and this is like very common. So this is like very common analysis that you would run. You would run like a bar chart where you have a numerical data and a categorical data. So if you have two categorical data, this is like not very common that you will run two categorical data together, but there are instances where you just want to know what is like the association between sex and rurality, like do females stay in rural area more or urban area more? So you have something like this. So type of analysis you can run is like a chi-square, bar chart, tables, and counts. So count is like you're just counting. It's not like mean, median, and mode. Like you're just even having a count instead of having doing the mean, like a total. So this is like a This is a table, or I think this is a chi-square association. So chi-square association is for or chi-square. Right. So because most of the things you're not seeing here, because they probably give you just one singular result. So a chi-square is going to, when you run a chi-square for two categorical data, it's just going to give you a number, I guess from 0 to 1. So if it's also like closer to 1, that means it's a very strong association. If it is lesser than, if it's very low, then it means that there's a weak association between those two variables. So this is like you running a table. Look at this. This is just a table. It shows a categorical data. This is their feelings. Do they like something? Neutral, like, they do not like it. So by gender, so we can see for male and female, 7 females doesn't like, 5 females like. So if you see we have 108 males love statistics, 99 doesn't love. So you can compare two categorical data with a table. So this, they are using count, right? So tables do a lot. Also, a lot of people undermine the power of a table. So it's not all the time you would have to run bar charts, graphs all the time. So tables could also show you something or great insights. There are some software that are limited in the kind of way they will show results. So you just have to make do with the software that you're using. Moving on. So when you have multivariate levels of analysis, so you can do like a grouped bar chart. So bar chart is very like one of the widely used visualization we use as data analysis. So there are different kinds of bar charts that you would find out there. So group bar charts, measures of central tendencies, counts, scatter plots. Remember, for multivariate, that is where you have 3 or more variables. So in this instance, you can have 2 numerical, 1 categorical. You can have 3 numerical, 2 categorical. So it's like you have a lot of variables. But most times when you have a lot of variables and you're trying to look at their relationship, so what you do is a regression. So because you can only put in a plot if you have, let's say, 3 to 4 variables. You can't have like in a plot like having 6 variables showing in one single plot. Like it's going to be very messy and confusing. I mean, the most I've seen is like people use is four. Like three is a good number. Like that's what you want to have, like three variables communicating together in one plot. Um, so this is an example of, so like I said, always pay attention to the X and Y axis. So this, let me tell you the three variables that are here. So one variable that is here, it's a numerical variable showing the number of votes. Another variable that is here is a categorical variable showing the year of election. And that variable that is here is showing like the people that voted. So this is like categorical variable. So this is three variables. So this makes sense, right? So what this person did here was to show in 2012 and 20. So we can compare 2012 to 2013 first of all without looking at anything. So we see that for almost everybody, like or for three persons, not almost everybody. So for Jessica, Jessica voted, like had more votes. I think not voted. So this Jessica had more votes in 2013 compared to 2012. So William had more votes in 2012 compared to 2013. So and we can see on and all, while Peter had lesser votes in 2013 compared to 2012. So then we can see the number of votes on the y-axis, and we can see for each person. So that means what can happen is that we can actually have two bar charts from this. Imagine you take out all the reds, that's all the 2013. So you do the same bar chart for 2012 separately and 2013 separately. So then you can see, so all you just be seeing is just compare Jessica to Williams to Usain to Peter to Meredith. But right now we can compare not just Jessica to William, but we can compare Jessica to Jessica, Jessica of last year to Jessica of this year. So that's the beauty of data analysis, right? So you can have this power to show stuff in just one visualization, and people can make sense of an information. So what's like your decision? So if you have a question and you want to say, oh, did the voting increase from 2012 to 2013? So that could be one question. Another question could be like, who has the highest votes? Another question could also be, what's the number of votes compared to for, let's say, Jessica and in different years. So imagine you have like a different like analysis again, like you now add it to this bar chart. It's going to look very messy. I could read this bar chart because I've been doing analysis for a while, so that's why I can easily read this. For someone who doesn't even know much, they will take a while and try to understand what does this mean. So that is why when you're also running your analysis as a data expert, you should know what you are doing. So you can explain and say, okay, this is what this mean. And also, so there are different type of visualizations. So we just covered like a very few ones, and the ones that are very popular. Like I said, there's donut chart. There's if you are using the Power BI or using like other tools, they have like more ways to do some visualization. So one of the things you want to do is that first of all, you want to ask yourself, is this appealing to my eyes? Like if something is not appealing to your eyes or so appealing to your friend or someone to like, do you mind helping me check this out? Just know that probably this is your analysis is wrong. And that way you could also learn about more about visualization ways is to look at what others or the ways others are showing their visualization. So you see this person just showed like the net profit. This is also a visualization. This is just showing a certain number. This is a bar chart that is slanted. This is a bar chart that is also showing like a line graph. This is a line graph. This is a donut chart. This is a visualization that's like, I probably don't know what the name is. So it's just like trying to, so this is all this together, they call them a a dashboard. So when you have different visualizations together in a snapshot, it's called a dashboard. But most times you wouldn't work with dashboard because you probably would work with like trying to do an analysis one at a time. It's when you're writing a report and you just want to have like, well, what is the most for that analysis? Now you would have like a dashboard. So then you get better by doing more, and it's very important that you know what is right and what is wrong. So some of the things we've shared like in today's teaching is kind of like give you like an insight of, oh, this is like when I say categorical data, when I say numerical data. So it will take a while for you to process those type of analysis. After you process them and you've done some analysis for a while, you would not be processing. It's just automatically. Um, Remember, the difference between a bar chart and a pie chart is that a bar chart has space. A pie chart, sorry, a difference between a bar chart and an histogram is a bar chart has space in the bars, while a pie chart, a histogram doesn't have space. I think I'm just going to show you what that looks like. Let me show you. Let me show you what that looks like. So this is a bar chart. Okay, let me show you a singular bar. So this is a bar chart. So a bar chart is for a categorical data. So you have space in the bars. So this is one of the first ways I was able to differentiate between a bar chart. This is a bar chart. You have space in the bars. This is a bar. This is a bar. But histogram, you do not have space in the bars. So this is an histogram. This is an histogram. You do not have spaces in the bars. So if somebody wants, if you're not sure if something is an histogram or a bar chart, histogram, no space in the bars. Bar chart, you have space in the bars. And histogram is for numerical data. Bar chart is for categorical data. So let's show some example of bad visualizations. So you're like, what is wrong with this? So what they did here, this is actually a real analysis. So what they did here was on the x-axis, it's a like month. So they had January, February, March. It is a lot going on here. Is that this is a month? This is a month. This is the days of the month. This are two variables. This is new cases combined. This is cases, that's the fourth variable. No, this is third variable. Okay, month, days to second variable is the third variable, fourth variable, and this is on the y-axis, the fifth variable. This is too much. This is one problem with this. Like you can't necessarily even say what this is saying because like what does this mean? You would have to look into it closely. Now, what they are trying to show is they're trying to show the COVID-19 cases by days. Now, the issue with that was the fact that technically we can take this month. It's this month are categorical data. Awesome, they're nice. What could have happened was if they ran it for January separately. But the issue was also the fact that they could have done what is the average COVID-19 cases for the month of January. So they kept doing 21, 23, 24. So when you have two levels of categorical data, when you have two levels, so like let's say you are doing something like it's a number of countries, right? Like, and you want to do like the population for each country. Let's say we have 200 countries, and in your bar chart, you have 200 bars. Nobody's going to see that. So you don't want to have more than 10 bars. So if you have a categorical data and there are just so many levels, so think about another analysis you want to run, or you can try to group some together. So for countries, you can group them into continents and say, okay, let me bring Africa together, let me bring North America together. Then I can show the bar chart based on this continent, because when you have too many levels, it's messy. Like you don't want to run a bar chart for it. So another thing is like this is like months and days. So days you can think of days as a categorical data, as a numerical data also. So like this is bad. So don't run your analysis like this. Another one is this, you are like, what is wrong with this? So what they did here is, so look at the x-axis, look at the y-axis. So on the x-axis you have for 2009, so it says the percentage of Americans that identify as Christians. So it says in 2009 77% of Americans identify as Christians, while in 2019 65% of Americans identify as Christians. Now if you do not look at these numbers, this is quite misleading, because look at the big jump from 77 to 65. It looks as though like this is almost half. That means what you'd expect this batch to be should be like 35 or 38. So, but this is a wrong way. What they did was, so they changed the scale. So this will move from 58 to 68 to 78. So one way people manipulate results is to change the scale of their y-axis, right? So this is wrong. So you don't want to do this as a data analyst or a data expert. You want to have, most times you want your scale to start from 0. So, and you want to have like an equal number. So it's either it's going from zero. Imagine this goes from 0, 25, 50, 75. You will see that this result is going to look different. So that's also a bad visualization. Another one. So you see here, the issue here was with colors. So almost like Tuesday almost and Saturdays and Sunday and Monday almost has the same color. You cannot necessarily differentiate. Um, these bars, they are going a little bit okay, but it's just messed up. Like I don't know what they're trying to do, but this is not very bad. And that thing here is that look at this. So the bad thing about this one is because of the labeling. So this bar is okay. It says 62% is family getting it. 68% the economy, 48% getting it. What does that mean? Like biggest COVID-19 worries, getting it, family getting it. So you need to label things well, like for you to understand what do you mean getting it? What do you mean family getting it? What do you mean the economy? For someone that is getting it, your family could also be getting it. So that's one of the good job you want to do as a data expert. So conclusion, so there's a lot. So this is like a starter for you to know what you want to do. I would highly encourage that you go back to watch these videos again when you are running analysis. You could pause and play. Oh, I remember that I watched somewhere in the video that says I should not do this or I should do this for a particular type of variables. So read more, familiarize yourself with this explanation. Remember, it's a journey, so 1,000 miles start with a step, and just be curious and set goals and remember that you can do this. In case you love to learn more, so we release videos just for your learning. You can visit our website at www.velonti.com or check us on our social media page on LinkedIn, Twitter, and Instagram at Velonti_VT. And if you would like to learn more, so try to turn on your notification bell, subscribe to our YouTube channel, and share to your friends. I mean, it's for free. Thank you.